Hello, welcome to Microsoft Azure Cloud Channel. In this module, we will talk about how to use the Azure Machine Learning Designer to train and deploy a machine learning model. In this module, we will learn how to create a new pipeline, import data, prepare data, train a machine learning model, and evaluate a machine learning model. So in this module, we will learn how to use the Azure Machine Learning Designer to train and deploy a machine learning model that predicts the price of any car. I'm in Azure portal. In order to use the designer, we first need an Azure Machine Learning Workspace. The workspace is the top-level resource for Azure Machine Learning. It provides a centralized place to work with all the artifacts we create in Azure Machine Learning. Let's go to search, just enter Machine Learning and click on Machine Learning. Click on Add. We need to create a resource group. I will just say Machine Learning Resource Group. And we need to select a name for our workspace. I will say ML Workspace 1 and region East US. And we need to select Workspace Edition. There are two available, Basic and Enterprise. Let's select Basic. Click on Review. Everything looks good, validation passed. Let's deploy this workspace. It takes a few minutes. Our deployment is complete. Let's go to resource. So here we can see Azure Machine Learning Studio. Let's launch Machine Learning Studio. So now I will create, before we create a pipeline, so we need to click on Designer, upgrade it to Enterprise. Now it is upgraded. So now I will create a pipeline. Click on Designer. And here we can see a new pipeline. Click on New Pipeline. Azure Machine Learning pipelines organize multiple machine learning and data processing steps into a single resource. Pipelines let you organize, manage, and reuse complex machine learning workflows across projects and users. So now we need to set the default compute target. On the right side of the canvas, we see default compute target. No compute target selected. Let's click on select compute target. So we don't have any existing compute targets. Let's select create new. And here we can see that the recommended one, compute target configuration. So Azure recommend using below predefined configuration to quickly set up our training compute target. So I will select this one. So if you need another one, so we can go to compute training clusters to create customized compute target. If it is not suitable for your needs, we can always choose our compute target based on our needs. So here I will just choose this predefined one. So I need to give a name. Let's say compute 01. Click on save and click on save. Now I will go to the left of the pipeline canvas as a palette of datasets and modules. So I will click on datasets and click on samples and select automobile price data and drag it here. And we can visualize the data to understand the data set that we will use. So in the module details pane to the right of the canvas, we can select output, but here just click on automobile price data right click on it, and here we can see the option visualize dataset output. Click on it. So each row represents an automobile, and the variables associated with each automobile appears as columns. There are 205 rows and 26 columns in this data set. So here we can see the data. Just go on right, and we can see the price. So in this model, we are predicting the price of the car. So this is the price. So let's close this. Now we need to prepare the data. Data sets typically require some pre-processing before analysis. We might have noticed some missing values when we inspected the data set. So these missing values must be cleaned so that the model can analyze the data correctly. So I will remove a missing data column. So let's go to module palette and click on expand data transformation section and choose select columns in the data set. Drag it here. And now let's connect this automobile price data to select columns in data set. So select, and on the right of the canvas, we can see the edit column option. Let's click on edit column. And here we see the option include column names. So let's select all columns include, and we can add one more rule, and let's select exclude and column names. So the normalized losses column doesn't have proper data. So here we are excluding this normalized losses and click on save. Now let's add clean missing data stuff. Our data set still has missing values after we remove the normalized losses column. So we can remove the remaining missing data by using the clean missing data module. So let's go to data transformation section. So on the left of the canvas, we can see clean missing data. Drag it here and connect select columns dataset to clean missing data. So on the right of the canvas settings, clean missing data settings, click on edit column and then include column names, all columns, and save it. And in the module details pane to the right of the canvas, we need to select remove entire row under cleaning mode. So here under cleaning mode, select remove entire row. And save it. And we can enter the comments on each box. So let's go to select columns datasets in the comments. So here we excluded normalized losses column. So we can just say exclude normalized losses. So comments will appear on the graph to help us organize our pipeline. Let's click on clean missing data. So here we can enter, we can just say remove missing value rows. Now that we have the modules in place to process the data, now we can set up the training modules because we want to predict price, which is a number. We can use a regression algorithm. So for this example, we use a linear regression model. So I will add the split data. Splitting data is a common task in machine learning. We will split our data into two separate data sets. One data set will train the model and the other will test how well the model performs. So here in the data transformation, so we can see that split data. So let's drag it here, split data, and connect left port of the clean missing data module to the split data module and select split data. And we need to enter a number here, fraction of rows in the first output data set. So I will just select 7. This option splits 70% of the data to train the model and 30% for testing it. The 70% dataset will be accessible through the left output port. The remaining data will be available through the right output port. Now under the command, let's say split the dataset into training set 0.7 and dataset 0.3. Now let's add a train the model task. Train the model by giving it a dataset that includes the price. The algorithm constructs a model that explains the relationship between the features and the price as presented by the training data. So on left side of the canvas, I just close this section, data transformation. So let's expand this machine learning algorithms. Let's select linear regression, drag it here, and close these machine learning algorithms sections and expand model training and bring the training model here and connect linear regression port to the left port of train model and connect left port of split data to the right port of training model. Now let's click on a train model, edit column. So in the text box, enter price column to specify the value that our model is going to predict. So here we choose price column and make sure we shouldn't capitalize, and we need to make sure we enter the column name exactly. So here is our column. Here in this model, we are using the field price. Save it. Now I will add the score model module. After we train our model by using 70% of the data, we can use it to score the other 30% to see how well our model functions. So on the left side of the canvas, just close these modules, close module training palette and go to search and just type score model. So here we see the third one, score model. Let's just drag it here. So now I will just reduce this. Now we can see better. So I will just move this task a little bit up so that we can see the complete flow. And now I will connect this train model to the left port of score model, and then split data, a right port, I will connect it to the right port of score model. So 70% we will use, and then split data 30% we will use. For this 30%, we use how well our model functions. And I will add one more, evaluate model. We use the evaluate model module to evaluate how well our model scored the test data set. And in the search, just enter evaluate, and we see evaluate model, just bring it here and connect score model to the evaluate model. Now that our pipeline is all set up, we can submit a pipeline run to train our machine learning model. We can submit a valid pipeline run at any time, which can be used to review changes to our pipeline during development. So on top of the canvas, we can see two options, submit, publish. Click on submit and select the compute and save it, and then click on submit. And we need to create a new experiment name. I will say experiment 01 and submit this. If it's the first run, it may take up to 20 minutes for our pipeline to finish running. The default compute settings have a minimum node size of 0, which means that the designer must allocate resources after being idle. And we can see our pipeline is running. So we can monitor this pipeline using the options pipeline. On the left, just click on pipelines. And here we see that our pipeline experiment 1, just click on it. And we can see that graph, and then even in the steps, we can see each step status preparing. And here we see the status preparing and the other not started yet. After the run completes, we can view the results of the pipeline run. It takes a few minutes for the pipeline to complete. Now the pipeline is in the last steps, score model completed. Now the evaluate model is not started yet, but we can still look at the results. We can view the results of the pipeline run, and we can look at the predictions generated by the regression model. And let's select the score model module to view the output. Let's select score model and right click on it and visualize the score data set. Here we can see the predicted prices and the actual prices from the testing data. So here we can see that actual price and then predicted price. Actual price 9,639 and then predicted price 10,909. And let's close this, and then let's check the evaluate models. We can use the evaluate model to see how well the trained model performed on the test data set. Let's select evaluate model, right click on it and click on visualize evaluation results. We can see the following statistics: mean absolute error, root mean squared error, relative absolute error, relative squared error, coefficient of determination. Mean absolute error is the average of absolute errors. An error is the difference between the predicted value and the actual value. Root mean squared error, the square root of the average of squared errors of predictions made on the test dataset. Relative absolute error, the average of absolute errors relative to the absolute difference between actual values and the average of all actual values. So far in this module, we covered how to use the Azure Machine Learning Designer to train and deploy a machine learning model that predicts the price of any car. And we covered in this module how to create a new pipeline, import data, prepare data, train a machine learning model, and evaluate a machine learning model. If you have any questions on this Azure Machine Learning Designer, please post in the comments. If you like this video, please subscribe and share the channel. Thank you.